So we're going to start with Chapter 1, Section 1, and we're only going to cover one section today. And just make sure you can see the screen there. I've tried to place it in a position where you should be able, where everyone can see it. You should be able to see it. We're going to start with 1.1. Now, if you ever have any questions, don't ever hesitate to ask me questions. I can slow down. I can explain things in a different manner. Never, ever hesitate to ask a question. If I'm moving too quickly, be sure and say something as well. So we're going to go ahead and start with 1.1. And we're going to begin with a couple of basic definitions. And when I give you definitions, I like to write them in language that you can understand, and not the same as the textbook. So 1.1, we're going to look first at equations and expressions. So an equation has an equal sign and can be solved. And let's look at some examples of an equation. So 3x minus 4 equals 12, and 8x plus 3 equals 9. So we're just going to start off with some very, very basic definitions. So in an equation, it has an equal sign, all right? And we're going to be able to solve it. Now, there's three types of equations, and we'll discuss those later on, but we need to learn the basic definitions and the difference between an equation and an expression. So an equation, it has an equal sign. An expression has no equal sign and cannot be solved. You might be able to simplify an expression, but you can't solve it. To solve it, you have to have an equal sign. And so here's some examples of expressions. 5x plus 9. 3x minus 5. Those are expressions. Right? And what's the difference between an equation and an expression? Well, it's just the equal sign. Now, in this course, and especially in this chapter, we're going to focus primarily on equations. But you do need to know the difference between an equation and an expression. In case I ever say an expression, you know what that means. So now we've talked about the difference between an equation and an expression, and now let's move on and let's talk about the three types. Okay? And when we talk about the three types, the first one is conditional. And a conditional equation can be solved for a numbered answer. So we're going to say can be solved for a numerical solution. So we're going to be able to solve it for a numerical solution. And most equations are conditional. So here's an example. How about 5 times 3x plus 4 equals minus 2 times about 7x plus 4. So this is going to be an example of a conditional equation. So we're going to review how I would begin to solve this. So whenever I solve equations, the first thing I always do is I get rid of my parentheses. And so I like to draw arrows whenever I distribute. So I'm going to draw arrows here when I distribute that 5 through. And then on the -2, I like to circle it because it's negative. That way I don't lose my sign. So I just circle it because it was negative. And I'm going to go ahead and distribute that 5 through on the left and that minus 2 through on the right. So when I distribute that 5 through, we've got 5 times 3, that's 15x. 5 times 4, that's 20. On the right-hand side, watch your negative here. Minus 2 times 7, it's a minus 14. Bring down the x. And minus 2 times 4, that makes it a minus 8. We're all right with that so far. So this is just using the algebra skills that you should already kind of know. We do want to solve this, so what do? When we solve, we want to get the variable on the left, numbers on the right. So I'm going to add that 14x over. And then I'm going to subtract off that 20. And 15 plus 14, well, that makes it a 29x. The 20s can cancel. The 14x's, well, they cancel. And minus 8 and minus 20, they go together. And that makes it a minus 28. Is everyone all right with that so far? Now, when we solve it, what do? Yep, we divide, so we get our x by itself. So we divide by our 29. And then our answer now is x equals a minus 28 over 29. Leave it as a fraction. Do not turn it into a decimal. The only time that we want to use a decimal is when there's already decimals in the equation to begin with. Otherwise, we keep it as a fraction. So that's going to be your answer. Since we got an answer, it's conditional. Conditional just means there's a condition or a number that makes it true. So in our case, that was the answer, and so it's conditional. The other two types of equations aren't used as often, but they are the contradiction and the identity. And we're going to start with the contradiction. And the basic definition of a contradiction is a false statement. And here's how I remember what a contradiction is. I think of if I go to court and they accuse me of giving contradictory testimony. Okay, that means we lied, right? Contradictory testimony in a court of law means you lied. Same thing here. A contradiction is a false statement, so it's something that doesn't make sense. So here's an example of a contradiction. About 4 times 3x plus 7 equals about 11x plus x minus 9. So this is going to be a contradiction, false statement. So what do? I begin by distributing that 4 through. So we just distribute or we push through that 4. So 4 times 3, that makes it a 12x. And 4 times 7, well, that's a 28. On the right-hand side, we have a 11x and another x. That makes it a 12x and a minus 9. Now, when we move the 12x over, the variables cancel out, and now I'm left with 28 equals a negative 9. And does 28 equal a negative 9? Is that something that could happen? No. So that means this is a false statement. It's a contradiction. And we represent that with the empty or the null set. Okay, that 0 with the slash through it, that's called the empty or the null set. And it just means that there is no number that would ever make it work. It's a contradiction. The last type of equation, and we don't encounter it very often, is the identity. And in an identity, the sides are the same. Now, how I remember identity is I think of identical twins. And what do you know about identical twins? Well, they're the same, right? Okay, so when I say identity, that means the sides are going to be the same. Now, they may not look the same to begin with, but we're going to apply a little bit of algebra and make them the same. So here's an example of an identity. How about 4 times x plus 11 equals, how about 4x plus 55 minus 11. And these are just very, very basic examples. We'll talk about more complicated ones here in a moment. But these are just going to be our basic examples. Now, these are going to actually be the same once we start working with them. So we're going to go ahead and distribute that 4 through. And then the 55 and the minus 11 can also be combined together. So we'll distribute that 4 through, and that's going to give me 4x plus 44 on the left-hand side, and the right-hand side is 4x, right? And 55 minus 11, well, that makes it a 44. And now what do you notice? We don't have to do anything else, because once they are the same, this is an identity. And the solution set for your identity is all real numbers. Okay, so this would be an identity for your solution. And it's all real numbers for the actual answer. So it's classified as an identity, and your solution set is all numbers. You can also use negative to positive infinity. I use all real numbers because that's what your textbook uses. So those are the 3 basic types of equations. Now what we have on the agenda today is we're going to cover more equations. So we're going to learn how to work with equations that have fractions. We're going to learn about square brackets next. Then we'll talk about literal equations. We'll talk about the difference between a linear and a nonlinear equation. And then at the end, we'll talk about simple interest. So quite a few topics left, but we'll go through these pretty quickly. So let's learn how to solve an equation that has square brackets. So let's say I give you this one. And it's going to be very similar to your first question on your homework. But on this question, we have square brackets. Now, why do we use square brackets? Well, we use square brackets because we already have parentheses. And we don't want to use a whole bunch of parentheses because it gets confusing. So square brackets are going to behave exactly the same as parentheses. And we work from the inside and we work our way out, combining as we go along. So we're going to go ahead and solve this. And we're going to do our parentheses first. So we're going to distribute the 3 through here and the 3 over here. So we'll bring down that 4. And then what we have left over is we have a 3x minus 3 plus 4 inside of the square bracket. On the right-hand side, we're going to distribute the 3 through. So we get 3x plus 3, and then a plus 4. Now we can clean it up. So let's go ahead and clean this up here. We have a minus 3 and a positive 4. So that leaves you then with a 3x plus 1 on the inside. 3 and the 4 can go together, and that's going to leave you with a 3x plus 7 on the right side. Okay, if I'm going too fast, just be sure and say something, because I can slow down. But you see how we're combining them together here. Now, the last step is these square brackets behave exactly the same as parentheses. So we distribute that 4 through. And 4 times 3 makes it a 12x. 4 times 1 is a 4. And the right-hand side is a 3x plus 7. And now we just solve it. So when I say solve, what does that mean? Well, when I say solve an equation, that means you get your variable on the left, numbers on the right. So I'm going to go ahead and move that 3x over with subtraction, and the 4 over as well. So 12x minus 3x, that leaves you then with a 9x. The 4's cancel, the 3's cancel. And 7 minus 4, well, 7 minus 4, that leaves you with a 3. We'll divide by our 9, and you want to reduce this down. And 3 9s reduces down then into 1/3. And what type of equation would this be? Is it conditional, identity, or contradiction? Which one would it be? Okay, conditional. And why is it going to be a conditional equation? Because we solved it and we got an answer. All right, if you get an answer, it's conditional. So this is conditional. So that's how you work with square brackets. Next, we're going to focus on, and we're going to have to do several of these, we're going to focus on fractions. Now, when we have fractions in an equation, the easiest way to work with them is to clear them out. So that's what we're going to do first. Whenever we have a fraction, we clear them out by using the least common denominator. So let's work with this one here. So let's say I give you this to work with. Now, our goal is going to be to clear out these fractions. And then that's going to leave us with something that we can easily work with. And how we do that is we work with the least common denominator, the LCD. And I like to work with them in pairs. So I'm going to take the least common denominator of the 3 and the 5. So what's the least common denominator of 3 and 5? Well, do they have anything in common? No. So the least common denominator would be 15, right? 3 times 5 gives you 15. Now we take that least common denominator of the 15 that we found, and what's our next fraction? Half. So we take the least common denominator now of 15 and 2. Well, 15 and 2, do they have anything in common? No. So 15 times 2 is a 30. Now we have our least common denominator. So that's 30. So once we have that, now we take our original equation and we multiply it by 30. And I'm going to show you the absolute easiest way to clear out these fractions. What we're going to do is we're going to divide by the number down below, the denominator, and multiply by the number on the top, the numerator. So we're going to divide by the number below, multiply by the number on the top. So 30 divided by 3, 30 divided by 3 is 10. 10 times 1, well, that makes it a 10x. Next, 30 divided by 5 is a 6, right? 6 times 4 makes it a 24. Next, 30 divided by 2, 15, times 1, that makes it a 15x. 30 times 4, there's no fractions here. 30 times 4 should be 120, shouldn't it? Now we have something that we can work with. Now all the fractions are gone, and we can solve this very easily. So move that 15 over with subtraction. So that 15x got moved over. And then move that 24 over as well. And 10 minus 15. Now watch your signs. A lot of times where students make mistakes is you get in a hurry. Watch your signs here. 10x minus 15x. 15 is the bigger number. It's negative, so my answer is going to be negative. And 15 minus 10 is a 5. So that would be a 5x there, right? So 15 is negative, and it's a larger number, so my answer is negative. Different signs, I just subtract them. 24's cancel. The 15x's cancel. And then I've got 120 minus 24. And so 120 minus 24, that should be a 96, I believe. You can always check things with a calculator. So that's going to come out to be a positive 96. How do we finish it? Yep, divide by a negative 5. And we can now rewrite this. And so now we've got x equaling. I'm going to bring that negative up to the top. So x equals now a negative 96 over 5. And what type of equation would this be? This would be a conditional equation, right? You don't have to write conditional every time, but just be aware that they are called conditional. And that means there's a condition or a number that makes it work. Let's try some more fractions. So let's look at this one here. So this one, we're going to have to distribute those fractions out in front through. Then we'll clear out the fractions after that. So we're going to distribute that 1/3 through. And that 1/4 through as well. So let's go ahead and distribute that 1/3 through. Now, there's nothing on the bottom, so we just multiply the number on the top by whatever's out in front. So 1 times that 4x, that makes it a 4x and a 3 down below, right? So that's 4x over 3. And then we've got a minus 1 times 7. Well, that's a 7 over 3. So there's that piece. On the right-hand side, when we distribute through, we multiply. 1 times 1 is 1. 4 times 2 makes it an 8, and bring your x down with that as well. And you can either write that as x over 8 or 1/8. They are the same thing. And then we've got a negative. 1 times 3 is a negative 3. 4 is down below. Okay, now let's work on our least common denominators here. What's the least common denominator? And you can pick them in any order. I like to do them in pairs. I think it's easier if we do pairs. So what's the least common denominator of 3 and 8? Yep, 3 and 8 have nothing in common, so we're going to use a 24. And then what's the least common denominator of that 24? And we haven't used the 4 yet. So 24 and 4. Well, does 24 evenly divide by 4 already? It does, doesn't it? Okay. So the least common denominator of 24 and 4 would be a, 24, wouldn't it? Right? Because that's going to go in both of them. 6 is the divisional result, but the least common denominator would be that 24. So now we're going to multiply everything by 24. And what's our pattern? Divide, multiply. Divide, multiply. 24 divided by 3. 24 divided by 3 is 8. Okay. 8 times 4, that makes it a 32, doesn't it? Okay. So there's your 32x there. 24 divided by 3, that's an 8 again. 8 times 7, that makes it a 56. Bring down your negative. 24 divided by 8. 24 divided by 8, that's a 3. X there. And the next one, 24 divided by 4. 24 divided by 4 is a 6. Right? 6 times that negative 3 is a negative what? Negative 18. Now, all the fractions are gone. And now we can finish it. So now we move that 3x over. And we add 56. And we've got 32 minus 3. That should be a 29. And again, don't ever hesitate to use a calculator. So 32 minus 3, that makes it a 29. Bring your x down as well. All right. That 56's cancel. 3x's cancel. And then we've got 56 minus 18. Yep. That's going to be a 38, isn't it? Right. And watch your signs. 56 is positive, so that means your answer is positive. And 56 minus 18 should make it that 38. Now we divide by our 29. We don't make it a decimal. You leave it as a fraction, and it's not going to reduce. So my answer would then be 38 over 29. And it's conditional, right? Now I'm going to pick a couple of these from our textbook to look at as well. We're going to focus more on the fractions just because students struggle more with fractions than anything else. So we should be on about 110 here, page 110. Let's look at one of these that has fractions in it. How about question 16? So this is on page 110. Question 16. And if you don't have your textbook or don't want to dig it out, I'm going to write it up for us. So we're looking at page 110, question 16. We've got 7/4 x. Oh, wait, I wrote it wrong. It's just 7/4, so sorry about that. 7/4 plus 1/5 x minus 3/2 equals 4/5 x. So make sure I wrote it down right. Everything looks right there. where are we going to begin? Well, you could, if you wanted to, you could bring that 1/5 over and combine it with the 4/5. But why don't we just go ahead and clear out our fractions? Because I think that's going to be the easiest way to handle this one. So what's the least common denominator of 4 and 5? Can anyone tell me? Yep, 20. Okay. And what's the least common denominator now, because we've used the 4 and the 5, of 20 and 2? Well, does 20 already evenly divide by 2? Yep, so it's the same thing. It's 20 again. Now we can go ahead and multiply everything by a 20. And we're going to follow our same pattern of divide and multiply. Divide and multiply. 20 divided by 4, so 5, times 7, that makes it a 35. Yep, and we don't have an x there, so it's just 35. 20 divided by 5, that's a 4, times 1, that makes it a 4x. And then we've got 20 divided by 2, that makes it a 10. 10 times a negative 3 makes it a negative 30. Very good work so far. 20 divided by 5, that's a 4. And 4 times 4 makes it a 16. And don't forget to bring your x there. Clean this up a bit. So I'm going to put the 35 and the negative 30 together. So now we've got 4x plus 5 equals that 16x. I'm going to move that 4x over. And then I'm going to rewrite it. I'm going to put the x's on the left. I like to do that. So 16 minus 4, that makes it a 12x. And then that 5 will still stay there on the right. Yep, equals 5. Divide by our 12. And now we have our answer, which is x equals 5 twelfths. Is everyone okay with how I did that? And if you have questions, be sure to ask, because I'm here to help. And I can explain things and break things down further. Everyone okay with that so far? Okay. Let's look at another one. Let's look at question 32. And question 32, I believe, is going to be an identity. Move it up here. So this is question 32, and this is going to be on page 111. And it is 1/2 of 6x plus 20 equals x plus 4 plus 2 times x plus 3. And this one should come out to be an identity. And the fractions are actually going to clear themselves out. So we're not going to have to worry so much about this fraction because it's going to clear out on its own. Okay, distributing through. That 1/2 on the left and that 2 on the right. 1/2 of 6. Well, 1/2 of 6 is a 3. Bring down the x with it. 1/2 of 20 is a 10. On the right-hand side, we've got x plus 4. And then we've got a plus 2x. And 2 times 3 is a 6. The left-hand side is already done. But what about the right-hand side? Add those together. And we get a 3x plus what? Plus 10, right? And what do we know now? These are the same, right? So these are the same. So what is it now? It's an identity. And what is your solution set? All real numbers. Okay? Is everyone okay with that? So I picked that one because that was an identity. let's do another fraction question. And this one requires a different technique. This one's going to require us to use cross multiplication. So this one's going to require us to use a little bit of a different method here. So what we've got is we've got a fraction equaling another fraction. The easiest way to solve this is going to be cross multiplication. So we just simply cross multiply. So we draw our arrows and we cross multiply. And when we rewrite this, we have to use parentheses. So we're going to rewrite this. And we're going to write this as 5 times the quantity, 4x minus 3 equals 3 times the quantity, 6x minus 1. Okay. So simple enough there. Now we should know what to do. Now once you hit this step, what do? You distribute the 5 through and the 3 through. Distributing the 5 through, we get 5 times 4, so that's a 20x. 5 times a negative 3, that's a negative 15. 3 times 6, that makes it an 18x. And 3 times a negative 1, well, that's a negative 3. Move that up so we can see. Sorry about that. So we cross multiplied, and then we distributed that 5 through, and that's 3. Now we can finish it. So now I'm going to move that 18x over with subtraction and add the 15 over. And 20x minus 18x, that makes it a 2x. 15s can cancel. The 18s can cancel, right? And minus 3 and 15, watch your signs, that makes it a positive 12, doesn't it? A lot of times that's where students make mistakes, is the very easy part. So be careful with your signs. A lot of times I've seen students get in a hurry and they'll add those together and they'll get negative 18 or something like that. And be very careful and don't do that. So watch your signs. They're different. They subtract. Larger number is 15. It's positive, so my sign is 15. Divide by your 2 now, and now you've got your solution, which is x equals now what? X equals 6 for the solution. And this, by the way, would be conditional, right? Let's look at a contradiction. And then we'll move on, look at one equation with decimals. And then move on to literal equations. So we'll do a contradiction. Question 35. So again, this is page 111. And we're going to look at question 35. And it should be a contradiction. So 4 times x plus 7 equals 2 times x plus 12 plus 2 times x plus 1. Okay, so let's go ahead and work this one out and see what we've got here. So we distribute that 4 through and the 2's through on the right. So that leaves me then with a 4x, and 4 times 7 makes it a 28. Right-hand side, we have a 2x. 2 times 12, that makes it a 24. 2 times x, that's a 2x. And 2 times 1 is a Now we're going to combine. These can go together here. The x's can as well. So that means the right-hand side is a 4x plus, looks like 26. The left-hand side is 4x plus 28. Now what do we need to do? Well, we need to solve it. And notice when we move that 4x over, what's going to happen now? Yeah, the x's are going to cancel, and we're left with 28 equals 26. Well, 28 does not equal 26, does it? Nope, so that's false. So this is now a contradiction. And again, it has no solution. On and look at another one here. This one's going to be a decimal equation. So let's look at question 30. On the same page, page 111. Question 30. This is a decimal. This is going to be a conditional equation, but it does have decimals in it. And I know you've done decimals before, so it's nothing new. So there's your equation. Some instructors have you clear out the decimals. I don't think that's necessary. We have calculators, so we're just going to use our calculator here. So don't worry about trying to clear out the decimals. You could, but there's really no need to. To me, that seems like a lot of extra work and a place where students may make a mistake. So we've got calculators, so we're just going to use our calculator here. So just distribute through and use your calculator. So distributing through, that's 0.04x, and then we've got a minus 0.04 times that 12. That makes it a 0.48. Plus 0.06x, and that equals 1.52. So all I did there is I just used my calculator. And you could clear out the decimals by multiplying by 100, but why do all that? I think you're more likely to make a mistake. Combine these together. So those can go together. So that's 0.1x when we put them together, minus 0.48. And that equals 1.52, because those go together. Okay. Add your 0.48 to each side. And now we've got 0.1x equals, we'll put these together, that equals 2. Divide by your 0.1, and that should give you, I believe, 20. Yep, that comes out to be 20. And this, again, is conditional because we were able to solve it, and we got a solution. Okay, so decimals, just use your calculator. If you want to clear out the decimals, you can. I don't really feel it's necessary. I think you're more likely to make a mistake doing that than just using a calculator. So now let's look at some more topics in this section. We've got a couple more to cover. Not much left though, really. We've done the hard part already. We're going to look at now literal equations. And literal equations are simply equations that have more than one variable. So we're going to be looking at equations that have more than one variable. And I'm going to basically just stick with solving for y, because that's what you're going to be doing in Chapter 2 when we graph lines. So the ones I'm going to give you are all going to be solved for y. With a literal equation, I have to tell you what variable to solve for, because there's more than one variable. So we're going to solve these for y. And this is going to get it in what's called slope-intercept form, and you'll learn a lot more about that in Chapter 2. So here's our literal equation, and we're going to take this literal equation, and we're going to solve it for the variable y. So let's go ahead and solve this for our variable y. And to do that, the x needs to be moved to the right. So I'm going to subtract off that 4x. And so 3y equals now a minus 4x minus 10. We'll divide by our 3 and reduce it down if possible. Doesn't look like anything's going to reduce, so now we've got y equals a minus 4/3 x minus 10/3. And that's your answer. It's a literal equation because you have more than one variable. And I could give you more complicated ones. I'm focusing on this because this is what you're going to be using when we get to line equations. Because when we get to Chapter 2, it's graphing. When you graph lines, you always solve for y. So that's why I think it's important that we focus on that more than any other. Let's try another one. And again, same directions. We're going to solve it for y. And this looks like questions 2 and 3 in your homework. So 2 and 3 are going to be very, very similar to this. 2 is a little bit different. Just got to rewrite it, but same thing. So we want to solve this for y. So we're going to begin by moving that 3x over again. And minus 9y equals now minus 3x plus 14. Divide by our negative 9. And we're going to reduce if we can. And a negative over negative is going to make that positive. So we've got our y on the left. Negative and negative makes it a positive. And 3 over 9, well, that reduces down to 1/3. So that's going to be a 1/3 x. 14 and 9 have nothing in common. So that's going to be a minus 14 over 9. And that's called a literal equation. Okay. Now let's talk about, and this is the next part, is I think one of the easiest parts of this section. We're going to talk about the difference between a linear and a non-linear equation. And linear equations are what we've done today. So linear equations they only have x as the variable. Not any power. So not x squared, x cubed, the square root of x, or x in the denominator of a fraction. So if it has any of those, it's going to be nonlinear. Okay, so linear is what we've already done today. And There's a different definition in your textbook. I like to write it out in words, and I like to make the definition something you can understand. So linear equations, they only have x as the variable. And they're not going to have x squared, x cubed, square roots, anything like that. And these we're not going to solve. We're just going to look at these, and you're going to tell me if they're linear or nonlinear. So I'll give you 3 examples, and then we'll look at the homework as well for questions 12 and 13. So let's do a few examples, and you're going to tell me if these are linear or nonlinear. How about 5x plus 8 equals 3x? Linear or nonlinear? Well, first thing we look at, do we have any x squares or x cubed or any powers at all? Nope. Do we have any square roots? Nope. X is not in the denominator of a fraction, so this is linear. Linear just means lines. I could graph it as a line. How about the next one? How about 4x equals 3x squared minus 5? What would that be? Linear or nonlinear? Nonlinear. And why would this one be nonlinear? Yep, because of the x squared. And one more, just to make sure we've got these down, which it looks like we do. How about 4x equals the square root of 7 plus 3x? Linear or nonlinear? Nonlinear, right? Yep, and why is this one nonlinear? Because it's square root. And x can also be in the denominator of fraction. That would make it nonlinear. That's going to be next week. Next week, we're going to focus on nonlinear. This week, we're focusing on linear. All we've done so far has been linear. So let's just look at these 2 questions from our homework. 12 and 13. They're not designed to be difficult. What about 12? Do you think 12 is linear or nonlinear? Linear. Why is it linear? Because we have no powers, do we? Right? It's just x's. So 12 is going to be linear. What about 13? Nonlinear. The very last part of this section to look at is going to be simple interest. Okay, so we're going to look now at simple interest. And simple interest has this formula. I equals PRT. I is the interest. P is the principal or the starting amount. R is going to be the rate as a decimal. And T is years, not months, years. So T is a number of years. So here's our formula for the simple interest. Now, on Thursday, we're going to be looking at a lot more applications. Today, we're just doing this one time. But Thursday, we're going to be looking at mixture problems, investment problems, and all of those. But today, we're just looking at simple interest. Now, there's only 2 questions like this in your homework, and I'm going to work out one of them, and you can work the other one. So I'm actually going to work out question 14 from your homework. You can do 15. So we're going to look at 1.1 homework. We're going to look at question 14. I'm going to read it. We're going to talk about it. We're going to solve it. And then you're going to use that to do 15. So we're going to look at 14. Now, where we need to be careful at is with the years. T has to be in terms of years, so if we have it with months, we've got to divide by 12. So make sure you're aware of that. So Levi borrowed $7,129 at 4% interest for 6 months. How much will he have to pay in interest? And what will his total amount that he has to pay back be? So we need to find the interest and how much money he has to actually pay back. And we're going to round this to the nearest cent. So we're going to go ahead and look at that. Now here's our formula, again up at the top. I equals PRT. So let's write up our formula again and fill in the pieces. The interest, we don't know. That's what we're going to try to find. So that's the unknown. The principal is how much he borrowed. And it looks like he borrowed $7,129, right? And his interest rate is 4%. Yep, so that's 4%. We transform that to 0.04. Now here's where students make a mistake, time. He did not borrow this money for 6 years, right? He only borrowed it for 6 months. So we've got to take that 6 and we've got to divide it by 12 because that's half a year, right? Is everyone okay with that? So make sure when you read these that if it's in months, you divide it by 12. If it's in years, you're okay. But if it's in months, you've got to divide it. Or if it's in quarters, you would divide by 4. Now we're going to plug these numbers into our formula and multiply them through. So I equals 7,129, that's our principal, times the 0.04 times a half. And you can use 0.5 or you can just leave it as a half. Doesn't matter. We'll just keep it as a fraction. And what I'm going to do now is I'm going to multiply. I divide at the end. That way you don't have as much round off. So the last thing I'm going to do is divide. So I'm going to multiply across the top. So let me get the calculator up here so you can kind of see what we're doing here. So we're going to multiply across. So 7129. Multiply by that 0.04. That comes out to be 285.16, and we still got to divide that by 2. So I just multiplied them all, because 1 times that doesn't change it. And now I'm going to divide that by 2, and we want it to the nearest cent. So divide it by 2, round to the nearest cent. So that's $142. Yep, and 58 cents, isn't it? So that's the interest. So the interest is now $142.58. So there's half of it. We need to also determine how much he has to pay back. So the total to pay back. Well, the total to pay back would now be that $7,129. We're going to add to that $142.58. We'll add those together, and how much total do we have to now pay back? Okay, so it looks like $71.29. We're going to add to that $142.58, and that gives us a grand total then of $7,271.58. And that's my total that I have to pay back. So those are what I want for my answers. Now, I just did 14. Use that to work out 15. We should have now covered everything that you need to work through 1.1. So that's going to be your homework. So your homework now is that 1.1. I'm not going to pick it up on Thursday. If you've got questions about any of those problems, you can ask me on Thursday. And Thursday, we're going to look at applications. So that's going to be your homework. And I'll pick it all up on next Tuesday, right? So August 30th is when we'll do our first due date. So you'll hand everything in on Tuesday. Well, I will see everyone then on Thursday. And I hope you have a great rest of your day.